This video is about similar figures. These are the notes that we took in class. Using a centimeter ruler, measure the sides of the two rectangles, record the results of the table. Okay, so we've kind of filled in the numbers for you. So let's look at figure A, B, C, D. The length of AB. Here's A, here's B. And it tells us the length is 4. So CD would also be 4. The width of BC is going to be 1. The width of AD is going to be 1. Okay, we got those by filling out this right here. Both sides would be the same. E, F, H, G. So EF, from E to F, would be 2. From G to H would be 2. The width of EG, E to G, is 1/2, and E to H would also be 1/2. Are the side lengths between rectangles proportional? Okay, well, let's see. Let's compare AB and EF, which is I'm going to label this one the first triangle, this a rectangle. This is my second triangle. First, second. Okay, so let's take a measurement of AB over EF. Okay, so I did AB over EF of the first one. Then let's look over here to the second figure and look at BC and this is supposed to be FG. So we're going to compare the first figure to the lengths of the second figure. So remember, this was the first, this is the second, and it's going to be 1 to 1/2. So AB is 4, EF is 2. So I compared this line, which is 4, to this line, which is 2. Okay, so this was your first figure, this was your second figure. First figure, second figure. Okay, you've got to keep it consistent. Over here we have BC as 1 and the FG as 1/2. Okay, so let's simplify this. 4 divided by 2, because it's improper, becomes 2. And over here, since it's improper, if you divided 1 by 1/2, so I'm going to scoot over on let's see if I have some extra sheets around here. 1 divided by a 1/2. Let's just do it here. 1 divided by 1/2. Remember the rules of fractions. I'm going to keep it, change it, flip it. So now I have 1 times 2, 1 times 1. So I get 2. So this equals 2. So are they proportional? Yes. Okay. Similar figures. Are figures that have the same shape but not necessarily the same size. Okay, same shape, but not the same size. And we're going to find for x to see if they're going to be proportional. So again, we're going to take AB over here. We're going to say AB to BC. So AB would be 3, BC would be 5. And then D to E, okay, and you want them to be the same side of the triangle that we're comparing it to. So that would be 9, and the bottom would be EF, would be X. That's what we want to find. So I'm going to rewrite it here. 3, 5 should equal 9x. We're solving for x. Cross product, what we have been working on, it's not new. Multiply across, so 3x equals 5 times 9. 3x equals 45. Divide by 3, divide by 3, x equals 15. Okay, so this would be 15 meters. Okay, let's look at our homework. I believe you are doing all of the front, 1 through 7. So I'm going to start with 3. We kind of helped you in class on 1 and 2. So we're going to start with 3. Each pair of polygons is similar. Determine the missing side measurements. So we know that they're similar, so all we're going to do is find for x. So I like to use my highlighters on this section, this topic. So number 3, we have an x on figure 1. You can set up these problems many different ways. So I like to try to keep one triangle versus the other triangle. Let's show you how I would set this up. So on the first triangle, my second triangle, on my first, pick a side. So I'm going to pick 8. You have to make sure that the triangles are turned correctly. See the double lines here? That means those angles are the same angles. They measure the same. These would measure the same as those. So it is setting up right, unlike number 1. So with the first triangle, I have 8. I'm going to do 8 over x. And that's going to should equal to your 4 over your x. Okay, so 4 over 2.6. So you see, these are both the pink lines. These are the yellow lines. Now, I could have set it up differently. I could have said, okay, let's do pink to pink, yellow to yellow. So I could have had 8 to 4 should equal x to 2.6. So I took this side and compared it to this side and x to this side. But this is why it doesn't matter which way you choose to set it up, which is easiest for you. It's because you're going to come with the same outcome. Both of them are going to be 4x, 4x. So 4x, this is cross product, okay? Multiplying straight across. So 4x, 4x, 8 and 2.6, 8 and 2.6. So that's how it works. Whichever way you choose is the easiest is up to you, as long as you are lining them up the same. Sometimes it's a little easier to say this is my first figure, this is my second figure, but you have to keep the sides on, same sides on top, same sides on bottom. Or refer to side 1 on figure 2, x the bottom on figure 1 to the bottom of figure 2. Either way works. Just pick a method that you like. Okay, so find x. What is x? Let's look at 5. Number 5. Rectangle A, B, C, and D. I'm a visual learner, so I like to draw a picture. So here's a rectangle, and they're similar. Here's another rectangle, and it tells me that they are similar. So we're going to go A, B, C, D to W, X, Y, Z. What is the value of AB? Okay, so I want to know what is my value from AB if WX is 8 feet and AD is 12 feet and WZ is 16 feet. Okay, I'm solving for X. So remember, you can set it up either way you want. I'm going to do it from figure to figure. I want to do this figure. I'm going to do 12 to X. The ratio should be the same from 16 to 8. Now then, as you notice, the top sides of my rectangle is on top of my ratios. My sides are on the bottom. So this is this figure, this is this figure. But the sides are the same that I'm comparing. So you have 16x equals 12 times 8. And you can solve for x. Okay, number 6. A green rectangle tile and a yellow rectangle tile are similar. The green tile has a length of 24 centimeters. So, hey, let's just draw it in green. Okay? This is number 6. So this is my green one. And we have 24 centimeters. And then we have the yellow one. I'll do it in orange because my highlighter is a little different. The yellow one would be 72 centimeters. But the perimeter, the green tile has the length of 24 and the perimeter equals 80. What is the perimeter of the yellow one? Is what we're looking for. So let's take what we know. This one I set up to be 24 over 80. Okay, so let's compare it. This would be 72 over what perimeter? That's what we're finding is x. Okay, so again, cross product. Find for x. Show your work. Number 7. The triangle, and I'm going to draw it out. The triangle DEF is similar to the triangle GHK. What is the value of DF? So I'm looking for DF if GK is 3.4. And then EF is 2.25 and HK is 9 inches. Okay, so again, we're comparing the sides. So let's decide which method we're going to use. I'm going to use this compared to this one. So I'm going to go side to bottom, side to bottom. And if you wanted to remind yourself, go side to bottom. Side over here is 3.4. Your bottom is 9. Comparing side to bottom, side to bottom. And then you do your cross product. You're finding for x. Finding for x. And I will give you a hint that it is going to be a decimal. Make sure you label all your answers with your units of measure. Okay, on the back, number 1. A drawing on transparency is 6.5 inches wide and 3 inches long. The width of the image of the drawing projected into the screen is 13 feet. How long in feet is the drawing on the screen? So, I'm drawing it out. We have 6.5, okay, and this is my width. It's how wide it is. And let's see. Oh, it's 3 inches long. Okay. Now the image, when they project it on the screen, it says the width is, okay, the width of the image of the drawing is projected on the screen. It is 13 feet. And that's your width, so we're going to put it with the other width. How long is the screen? Okay. So let's set them up. I'm going to set this one figure up compared to this figure. So I'm going to go top to side. You can put top to side if that helps keep you straight. So top is 6.5. My side is 3. My top is 13. My side is x. Solving for x. Cross product. you'll have your answer. Let's look at number 3. A small rectangle has the width of 4 feet and a length of 10 feet. So number 3 has the width of 4 and the length of 10. Okay, the smaller rectangle has a length of 12 feet and it has the perimeter. What is the perimeter of the larger? Okay, so we're going to have to find out what this is. But then it's asking for the perimeter. Okay? Remember, the perimeter is all of the sides added up. So we have to find x before we can figure this one out. Okay? So set it up. We're going to go side to bottom if we want. Side to bottom. For this figure, it's 4 to 10. And for this one, the side is going to be your x to your bottom, which is 12. Okay, cross product. You're finding for x. Now then, this is very important. Once you find for x, you must find your perimeter, which would be the measurement of all 4 sides added together. Find x, and then you're going to have to add all of those up and find your perimeter. The perimeter is your answer, not x. Number 5. Polygon ABCD is similar to the polygon FGHI. Each of the polygon ABCD is 5 times longer than the corresponding FGHI. Find the perimeter of the polygon. Okay, so we know each side of the corresponding polygons is 5 times longer. So, on number 5, we're going to take the top one, 2 inches, times 5.5, because this is 5.5 times larger. Okay, let's go to the 5. 5 times 5.5. Now we come down to here. 3 times 5.5. Go to the side. 3 times 5.5. Okay, so this would be the measurements of the new polygon. Right here. This would be the new polygon. But what was the question? Determine the perimeter of this new polygon, the larger polygon. So add all of them up, and that is your perimeter. Perimeter is your answer, not the sides, not the multiplication, but you have to show it, and you have to show your multiplication, but your perimeter is the answer. And please do not forget your unit rates. If you have questions, we should be in by 7:30.